Hello everyone. Today in this post we are going to talk about resolution of a vector. We know vector is a physical quantity who has both magnitude and a direction. Say for example, if a vector is like this, I can say this is, if it is having a magnitude A, it's I cap, saying that it is along x axis. Suppose if a vector is like this, so it is B, its direction is along y axis, so I can say j cap. So these vectors like what we have drawn now are having a particular direction, it's only along x axis, whereas the vector that what we say is only along y axis. So it's very clear in which direction they are. But suppose if I am having a vector like this, making a certain angle, say this is our x axis, this is our y axis, they are making a certain angle with the x axis, that is neither along x axis nor along the y axis. This is vector A. So this is not completely along x axis or not completely along y axis. We would like to know how much of that part of the vector is along x axis. So what I can do is simply I can draw a perpendicular line onto the x axis, that this is the origin, say this is the point P. I can draw another perpendicular line onto the y axis, let this point is Q. So I can say there is a right angle triangle OAP. Say for example, if I have written cos theta we know adjacent side by hypothesis, OP by OA. OP is nothing but OA cos theta. OA is nothing but the vector A cos theta. OP is nothing but the component of the vector along x axis. It is shown as AX. So it's very clear that it is along x axis. So we are resolving a vector into components, identifying how much of the part of the vector is along x axis and how much is along y axis. Similarly, in the right angle triangle OAP, if I have written sin theta, opposite side AP by hypothesis OA, that AP is nothing but equal to OQ by OA. That implies we can say OQ is nothing but equal to OA sin theta. OA is nothing but the entire vector's magnitude A sin theta. This is nothing but the y component of the vector. So this is the x component of the vector AX, this is the y component of the vector AY, who are having specific directions. Thus what we are able to say, a vector is having both x components and y components. So I can say A bar is now resolved into two components, AX, it is along x axis. To say it is along x axis, I am multiplying with the unit vector along x axis, which is nothing but I cap, and AY j cap. Thus we are able to resolve a vector into components like x component and y component. So if I want to study something along x axis, I will consider the components of x axis, and if I want to study something along y axis, I will consider the components along y axis. I can also write, say for example, in the given diagram as tan theta equal to opposite side by adjacent side. Opposite side is AP, adjacent side is OP. AP is nothing but equal to OQ by OP. So OP is nothing but, OQ is nothing but y component, OP is nothing but x component. So I can express the angle made by the vector with the x axis theta as tan inverse of AY by AX. Thus we can resolve the component into vectors. We can also represent the vector along a specific direction. This is how we need to know about resolution of the vectors. Thank you.